What's up, everybody, and welcome to OpenStax Algebra and Trigonometry, Chapter 11, Section 5, Matrices and Matrix Operations. Let's do it. Can we add any two matrices together? If so, explain why. If not, explain why not, and give examples of two matrices that cannot be added together. So the short answer is no, we cannot always add any two matrices together. And what it depends on is whether or not they have the exact same dimensions. So for example, if I have a 2 by 2 matrix, let's say 2, 2, 4, 7. I'm just putting in random numbers. And then I have something like this, right? See a nice skinny one, 1, 5, and 9. Okay, these don't have the same dimensions. 2 by 2, 3 by 1, right? Different. So when these are tried to add together, you cannot complete the operation. So that's how you do it. Done. Can both the products of AB and BA be defined? Okay, if so, explain how. If not, explain why. So I would say yes, it's possible, but it has to be very specific dimensions. So let me give you an example. So if I call this matrix A and I call this matrix B, okay, I know, first of all, that I can multiply A against B because the number of columns in A equals the number of rows in B. So that allows me to carry out the multiplication A times B, right? Now, vice versa, if I did B times A, in order to make sure that we could do B times A, I'd have to know that the number of columns in B is equal to the number of rows in A, which it is. So the moral of the story is, if the number of columns in the first matches the number of rows in the second, and the number of rows in the first matches the number of columns in the second, then yes, AB is defined as well as BA. Done. Does matrix multiplication commute? Meaning, is matrix multiplication commutative? So I would say the short answer is generally no. I mean, it can be the same, but in general, it's different. Here's a really easy example to see that they're different. For example, if I did A times B, what the final dimensions are going to be is a 2 by 2 matrix. You know, whatever it will be, we could calculate it, right? We go multiply, 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 and we add those together, and that sum is going to go up here, so on and so forth. But bottom line is it's going to be a 2 by 2 matrix, right? If I did B times A, that's actually going to produce a 3 by 3 matrix. So we already know they're going to be different matrices because they have different dimensions. So bottom line is it can in certain situations, but in general, it's probably going to be a different result. So for this one, they're asking us to add matrix C and D right here. And the good thing is, because they have the exact same dimensions, we can add them together. So let me show you how this works. Basically, anything in the same spot is going to be added to something else in the same spot in that matrix, right? So 1 and 10 are going to add together and make 11, and they still go in that same spot in the resulting matrix. 5 and 14 make 19. 8 and 7 here make 15. 92 and 2 make 94. 12 and 5 make 17, and last but not least, 6 plus 61 makes 67. So that is how you do it. Done. For this one, we're meant to subtract B minus E, and so everything in those similar spots are going to subtract each other with B going first. So we have 2 minus 6, which is negative 4. We have 14 minus 12, which is 2. 22 minus 14, which is 8, and 6 minus 5, which is 1. So that is how you do it. Done. For this one, they want us to do D minus B, but here's the thing. In order to do subtraction or addition of two matrices, they have to have the same dimensions. But look, they have a different number of, they have the same columns, but different rows, right? 1, 2, 3, and this one only has 1, 2 rows. So this one cannot be done, so we'll say no solution. So for this one, we're meant to do scalar multiplication. Scalar multiplication is where you multiply a constant against every term in the matrix. So for example, this is going to be 3 times matrix B. Let me put that up here real quick. 3, 9, 21, 12, 0, and 64. And the result of the scalar multiplication is, again, everything gets tripled. So that becomes 9, 27, 63, 36, 0 still, right? 3 times 0, 0. And then 3 times 64, that's 180, 192. That's how you do it. Done. So for this one, we're multiplying C times negative 4. So if we imagine a little negative 4 in front of here, multiplying every one of these terms, let's write out the resulting matrix over here. So it'd be negative 64 times 3 is negative 12, times 7 is negative 28, times 18 is negative 72. Down here, times 90 would be negative 360, negative 20, negative 12, and then times 29 would be 80, and 36, negative 116. That's how you do it. Done. So for this one, we're taking matrix D and we're multiplying everything by 100. So let's make some room because these are going to be big numbers, okay? So that's going to be 1800, right? Basically adding 2 zeros to every term. 1200, 1300, 800, etc., right? 1400, 600, 700, 400, and 2100. That's how you do it. Done. Now we're doing a little matrix multiplication, okay? And we're doing B times C. First of all, we want to know, can we even multiply these matrices? And I say yes, because the number of columns here matches the number of rows. Okay, let's write it out. So now another thing that's important to note is the final vector is going to be, you know, we said for them to multiply, or the final matrix, excuse me, we said for them to multiply, it has to be 3 and 3 like that. But then the resulting matrix is going to have the same rows as the first and the same columns as the second. So it's going to be a 2 by 2. Okay, so we're going to make a big one here so we have room to write. Now, this is how we get the values, right? We do the first here in that row times the first here in that column. 3 times 4 is 12 plus. And then we do go to the right to 6 and go simultaneously go down to negative 2. That's negative 12. And then 4 times 5, which is 20, okay? And that's just going to be one spot. Okay, so we'll just move everything over just to make a little bit more room. All right, now I'm going to use a different color just so you can see it a little bit better. Now we're going to go across again, but down the second column. So now we go 3 times 10, which is here. Let's write it up here, 30. It's going to go in this spot, but we're going to write it up there. And then 6 times 6, which is 36. And then 4 times 9, which is, again, 36. And these are all going to be added up. And again, like I said, that's going to go here. We'll put that in later. Okay, now we're done with that row. We've gone and hit both of those columns. Now we start down here. And now we kind of do a similar thing, right? We go that one against the first, against that one, and against that one. So it's this bottom row hitting this entire column. Okay, so negative 8 times 4 is negative 32. 0 times negative 2 is 0. Don't even have to write it, but whatever. 12 times 5 is 60. And these are going to be added up like so. And then last one. We're going to hit this bottom row against this final column here. So we got negative 8 times 10 is negative 80. 0 times 6 is 0. And 12 times 9 is 108. We got to add these up. Okay, let's put the final matrix down here. And we'll do a little bit of mental math as we do this. 12 plus negative 12 is 0, plus 20 is 20. 30 plus 36 plus 36, that's 72, that's 102. Then we have negative 32 plus 60, which is 28. Last but not least, negative 80 plus 0, which is negative 80, plus 108 is 28. So that is how you do it. Done. So for these two, before we multiply, we need to make sure that the first matrix has the same amount of columns as the second one, right, has rows, and they do, so they match up. But just remember, the final matrix is going to have 2 rows, the amount of rows that the first one has, and 3 columns, right, the amount of columns the second one has. Okay, let's write it out. So we're going to kind of look at B and D, and I'm going to multiply sort of in a color-coded way. So first, again, the first row hits that first column, so it's going to be like boom. Then we go to the right one and we go down one, and then we go to the right one and down one. So those are going to be what we're multiplying. And we have 3 times 2, which is 6, plus 6 times 9, which is 54, plus 4 times 0, which is 0. All right, that's the first one. Now we're going to go to a different color. And now we're going to multiply like so against this guy, right? So we go 3 times 3 is negative 9, 6 times 3, which is 18, and then 4 times 8, which is 32. So you see that pattern kind of repeats. Now we're going to go to a new color. Let's go to purple. And starting back at the front, once again, we go to the right as we go down here in that third column. So we go 3 times 12, which is 36. We got 6 times 1, which is 6. And then we got 4 times negative 10, which is negative 40. All right. I'm going to go ahead and remove all of these because it's going to get real confusing. So let's get rid of that, but hopefully that makes sense. Now we're going to change it up and we're going to do a new color. We're going to do green. And now we're on the bottom row. And then we reset and come back to that first column. So check it out. We do first times first, second times second, third times third. Let's write it out. Negative 8 times 2 is negative 16, plus 0 times 9 is 0, plus 0 times 12 is 0. Not too bad. Now let's go orange. Again, same order for this row, and then now we hit this column. So -8 times -3 is 24, 0 times 3 is 0, and then 12 times 8 is 96. Last one, let's go with this orange thingy. Then we got -8 times 12 is -96. Again, as this one goes right, we go down here. 0 times 1 is 0, and 12 times -10 is -120. Last but not least, we're going to simplify everything. Just make sure we have enough room here. So 6 plus 54 plus 0 is 60. -9 plus 18 is 9. Plus 32 is 41. 36 plus 6 is 42. Minus 40 is 2. And then over here we have -16. 24 plus 96 is 120. Last but not least, -96 minus 120 is -216. So that is how you do it. Done. So for this one, we're doing C times B. And before we can do that, we got to make sure that for the first matrix, the number of columns, which is 2, equals the number of rows, which is 2 as well. And that works. But then remember, the final matrix will have the number of rows of the first 3, the number of columns of the second, which is 3. So it's going to be a 3 by 3 matrix. So I rewrote these two, and then we're going to make a nice 3 by 3 over here. We're going to have a lot of room because we have to write it all in. Then we'll put a final version down there. Okay, let's do a little color coding. Now, we're going to start with red. Again, first row times first column. So we go 4 times 3 plus 10 times -8. That's 12 minus 80, or plus -80, depending on how you look at it. Then we got first row times second column. So we go 4 times 6 plus 10 times 0. That's 24 plus 0. And then we go third column, same thing, still first row. So 4 times 4 is 16 plus 10 times 12. So that's 16 plus 10 times 12 is 120. Cool, there we got the first row. Next, we're going to hit this times each one of these columns. But first, we're going to do this one times just the first. So -2 times 3 plus 6 times -8. So that's -6 minus 48. Then we're going to go second column, -2 times 6 plus 6 times 0. So that's -12 plus 0. And then we got the third one in purple. -2 times 4 is -8. And then 6 times 12 is 72. Cool, let's go to the last row. So we go again to that first column, 5 times 3 plus 9 times -8. So that's 15 minus 72. Then we got 5 times 6 plus 9 times 0. That's 30 plus 0. And then last but not least, 5 times 4 is 20 plus 9 times 12 is 108. So 20 plus 108. Okay, now let's give our final 3 by 3 after we add everything up. So 12 minus 80 is -68. Then we got 24 in the blues, and then we got 136 out here. -6 minus 48 is -54. -12 plus 0, -12. -8 plus 72 is 64. 15 minus 72 is 67. -57. And 30 plus 0 is 30. Last but not least, 20 plus 108 is 128. And that is how you do it. Done. So for this one, we got two things going on. First, we're multiplying matrix A by 4, and then we're multiplying matrix D by 5, and then we're supposed to add these together. But here's the situation. When we have scalar multiplication, right, that's fine. I can multiply all these by 4, and that's cool. I can multiply all these by 5, and that's cool. But I will not be able to add these together because the dimensions of the original matrices are different. And even if I do the scalar multiplication, it's not going to change the dimensions. It's going to be a 2 by 2 and a 3 by 3, and we can't add those together. So this is a no solution situation. Done. All right, so for this one, we're going to start by multiplying D by a scalar of 3, and then we're going to add it to 4 times E, okay? So we're going to write that out here. Now, first what I'm going to do is I'm going to distribute this scalar to every term in D, and then I'll do the same in E, then we'll add them together. All right, so as we distribute the 3, we got 3 times -8, -24. 3 times 7 is 21. 3 times -5 is -15. Then we got 3 times 4 is 12. You see, every position is retained. It's just multiplied by 3. 3 times 3 is 9, and 3 times 2 is 6. Then we got 3 times 0 is 0. 3 times 9 is 27, and 3 times 2 is 6. All right, here for E, we have 4 times 4 is 16, 4 times 5 is 20, 4 times 3 is 12, 4 times 7 is 28, 4 times negative 6 is negative 24, and we got negative 20 for 4 times negative 5. Bottom row, we got 4 times 1, 4 times 0, and 4 times 9 is 36. Now, as we add these together, every similar spot, right? So we got this spot here is adding to this spot and going to this spot. So negative 24 plus 16 is negative 8. 21 plus 20 is 41. And negative 15 plus 12 is negative 3. Second row, 12 plus 28 is 40. 9 plus negative 24 is negative 15. 6 plus negative 20 is negative 14. Then we got 0 plus 4 is 4. 27 plus 0 is 27. 36 plus 6 is 42. And that is how you do it. Done. All right, so for this one, the first thing we're going to do is we're going to multiply that scalar of 100 against D and that scalar of 10 against E, and then we're going to subtract the resulting matrices. So for this one, we distribute it to each and every position, so that becomes negative 800, 700, negative 500. On the second row, it's 400, 300, 200. And then on the third row, we keep that 0, 900, and 200, right? Basically adding 2 zeros to every one of these terms. Now we come to E, and we're going to add a single 0 because it's times 10. So we got 40, 50, 30, 70, negative 60, negative 50, 10, 0, and 90. All right, now we're going to subtract each and every term in their position. So negative 800 minus 40 first, that's negative 840. Next, we have 650, right? These two are subtracting. And then negative 500 minus 30 is negative 530. Then we got 400 minus 70 is 330. 300 minus negative 60, that's plus 60, so that's 360. 200 minus negative 50, that's plus 50, so that's 250. And then 0 minus 10 is negative 10. 900 minus 0 is 900. And last but not least, we have 200 minus 90, which is 110. That's how you do it. Done. So for this one, we're multiplying B times A, and we're doing it in that order. So I'm going to rewrite in that order. So remember, when we multiply matrices, it's the first row times the first column, and then we go first row times second column, etc. So we're going to go in this order with the color coding. 40 times negative 10 plus 10 times 5. That's negative 400 plus 50. Then we go to the next column, but still that first row. So we go 40 times 20 plus 10 times 25. That is 800 plus 250. Next, we go to the second row and restarting at the first column. So we go negative 20 times negative 10 is 200, and then plus 30 times 5, which is 150. Last but not least, we do this times this guy, right? So we go negative 20 times 20 is negative 400. Plus 30 times 25, which is 750. All right, now let's get the final. Negative 400 plus 50 is negative 350. 800 plus 250 is 1,050. 200 plus 150 is 350. And negative 400 plus 750 is 350. So that is how you do it. Done. So for this one, we're meant to do B times C. But the thing we have to figure out first is this even feasible? Because here we have 2 columns and we have 3 rows. And again, we're supposed to multiply like this, but then we're out, right? We don't have a third column to multiply that third row. So this is actually not possible. Done. So for this one, when they say B squared, it's really B times itself. So let's write that out now. Now, the important thing to recognize is you're not simply squaring each of these individual values, right? We actually have to follow that same process. So we're going to color code it again. First, we got first row times first column. So 40 times 40 plus 10 times negative 20. That's 1,600 minus 200, right? Or plus negative 200. Then we go and hit that second column. 40 times 10 plus 10 times 30. That's 400 plus 300. All right, now let's go to the next row down here. We got negative 20 back to the first column times 40 plus 30 times negative 20. That's negative 800 plus negative 600 or minus 600, same dealio. Last but not least, let's do purple. We got negative 20 times this last column, negative 20 times 10 plus 30 times 30. That's negative 200 plus 900. Okay, let's write this out in final form. 1600 minus 200 is 1400. 400 plus 300 is 700. Negative 800 minus 600 is negative 1400. And negative 200 plus 900 is 700. That is how you do it. Done. So this one's going to be quite a bit of work. We got b squared, which is b times b, then a squared, which is a times a, and then we have to multiply them together. So since order of operations says we have to do the exponents first, we got to square each of those first, and then we multiply the product. So we got a lot to do here. So first we're going to do b times b. So here we go. Ready? 40 times 40 plus 10 times negative 20. That's 1600 minus 200, or plus negative 200. Then we've got 40 times 10 plus 10 times 30, right? This, we go across the row and down the column, right? So we got 400 plus 300. Now we got down here, we got negative 20, again, across the row, down the column. So we reset negative 20 times 40 plus 30 times negative 20. That's negative 800 minus 600, or plus negative 600. Last but not least, we got negative 20 times 10 plus 30 times 30. That's negative 200 plus 900. All right, now let's finalize that. So b squared is 1400, 700, negative 1400, and 700. Boom. Now we got to do the same thing again, but with a squared. So it's a times a. Again, let's use that similar color coding. So first, negative 10 times negative 10 plus 20 times 5. That's 100 plus 100. Next, we got negative 10 times 20 plus 20 times 25. That's negative 200 plus 500. Then we got 5 times negative 10 plus 25 times 5. That's negative 50 plus 125. Last but not least, we got 5 times 20 plus 25 times 25. That's 100 plus 625. All right, let's finalize it. So we got 100 plus 100 is 200. That's going to be 300. That's going to be negative 50 plus 125 is 75. And then we got 725 down here. Okay, so we have a squared, we have b squared. Now we have the final multiplication, b squared times a squared. Okay, and this is these numbers are going to get pretty big. Actually, I'm going to make a little bit more room just in anticipation, and let's go. So we got 1400 times 200, which is 280000, plus 700 times 75, and that is 52,500, using a little bit of a calculator here because these are big numbers. Okay, next. We got 1400 times 300 plus 700 times 725. That one I can do in my head. That's 42,000 plus the product of 700 and 725, which is 507,500 on the calculator. All right. Next, we come back to the second row. We go boom and boom, right? So that is negative 281234 zeros plus 700 times 75, which is again 52,500. And then last but not least, we got negative 1400 times 300, 700 times 725. This is actually going to be identical to what's up here. If you think about it, it's just going to be, the first one's going to be negative. So it's negative 42,000, and then plus 507,500. Now to get the final matrix, we're going to do a little addition. So this plus that is 332,500. 420,000 plus 507,500 is 927,500. Then negative 280,000 plus positive 52,500 is negative 227,500. Last but not least, negative 420 plus positive 507, positive 87,500. And that is how you do it. Done. So for this one, based on the order of operations, we're first going to multiply a and b, and then that result we're going to square it. Okay, so first let's write them out in that order. So we're going to do a little color coding. We got negative 10 times 400 plus 20 times negative 20. So that's negative 400 minus 400. Then we got negative 10 times 10 plus 20 times 30. That's negative 100 plus 600. Then we got 5 times 40 plus 25 times negative 20. That's 200 minus 500. Last but not least, we got 5 times 10 plus 25 times 30. That is 50 plus 750. So now we have for A, B, let's add everything up and combine like terms. We got negative 8, or not like terms, but in the position. So we got negative 800 there. We got 500 here. We got negative 300 here. And then we got 800 here. Now that we have AB, we can do AB times AB, which is AB squared. So let's write out a matrix. And these are going to be pretty big values, so we got a lot of room. So let's begin. Negative 800 times negative 800 plus 500 times negative 300. That's going to be 640000, and then positive because the negatives cancel, and then minus 150000. Next, we got negative 800 times 500 plus 500 times 800. Now you notice those are going to be opposites, but let's still write them out. It's negative 400,000 plus positive 400,000. So then we got negative 300 times negative 800, and then 800 times negative 300. So that's 240,000 positive minus 240,000. And then last but not least, we got over here negative 300 times 500 plus 800 times 800. So that's negative 150000, kind of like here, and then plus 640,000. Last but not least, let's simplify and add everything together. So 640 minus 150, that's 490,000. These are going to cancel out to 0. These are going to cancel out to 0. And then this is going to be the same as this, positive 490,000. And that is how you do it. Done. So for this one, we're multiplying A times B, and this is doable as long as the number of columns here equals the number of rows there, which it does. And then the final matrix will have the same number of rows here and columns there. So it's going to be a 2 by 3, just like B. So let's write this out. So as we start this out, we're going to go first row times first column. Let's go 1 times negative 2 plus 0 times negative 1, which is 0. Next, we have 1 times 3 plus 0 times 1, which is 3 plus 0. And then we have 1 times 4 plus 0 times negative 5. And now we move on to the bottom row, right? So we got 2 times negative 2 plus 3 times negative 1. That's negative 4 minus 3. Then we got 2 times 3 plus 3 times 1. That's 6 plus 3. And last but not least, we got 2 times 4 plus 3 times negative 5. So that's 8 minus 15. All right, let's simplify. So we got negative 2, 3, 4. Negative 4 minus 3 is negative 7. 6 plus 3 is 9. 8 minus 15 is negative 7. That's how you do it. Done. So for this one, we're doing B times D, and as long as the number of columns equals the number of rows, we're good to go, and it does, so let's do it. So we got negative 2 times 1 plus 3 times negative 6 plus 4 times 4, and that is negative 2 minus 18 and then plus 16. Next, we go to the second column, so negative 2 times 0 plus 3 times 7 plus 4 times 2. That is 0 plus 21 plus 8. Next, we got negative 2 times negative 1 plus 3 times 5 plus 4 times 1. That is 2 plus 15 plus 4. And then we go to the second row. We got negative 1 times 1 plus 1 times negative 6 plus negative 5 times 4. That is negative 1 minus 6 minus 20. Then we got negative 1 times 0 plus 1 times 7 plus negative 5 times 2. So that is 0 plus 7 minus 10. And then last but not least, we got that times the third row. So we got negative 1 times negative 1 plus 1 times 5 plus negative 5 times 1. So that is positive 1 plus 5 minus 5. All right, now let's simplify. So we got negative 2 minus 18 is negative 20 plus 16 is negative 4. 0 plus 21 plus 8 is 29. 2 plus 15 plus 4 is 1921. Negative 1 minus 6 minus 20 is negative 27. 7 minus 10 is negative 3. Last but not least, 1 plus 5 is 6 minus 5 is 1. That's how you do it. Done. So for this one, we got D squared. So I'm going to write out D times D. And let's use a little color coding. And we're going to start with 1 times 1 plus 0 times negative 6 plus negative 1 times 4. So that is 1 plus 0 minus 4. Then we go to the next column, right? But the same first row. So we go 1 times 0 plus 0 times 7 plus negative 1 times 2. We got a 0 here and here, so it's just going to be negative 2. I'm not going to write out the other two zeros. Next, we go to the third one. So I got 1 times negative 1 plus 0 times 5 plus negative 1 times 1. So that's negative 1 plus 0 minus 1. Now we go to the second row, reset at the first column. So we got negative 6 times 1 plus 7 times negative 6 plus 5 times 4. That is negative 6 minus 42 plus 20. Okay, next we're going to go, let's go with this color. We got negative 6 times 0 plus 7 times 7 plus 5 times 2. That is 0 plus, what was it, 0, and 7 times 7 is 49, and then we got 5 times 2, which is 10. Great. And then we'll do, let's do this color. We got negative 6 times negative 1 is 6, plus 7 times 5 is 35, plus 5 times 1 is 5. So we got 6 plus 35 plus 5. Now we do the bottom row, and let's start with this color. So we go 4 times 1, so you're getting pretty muddled, but you see the point, right? 4 times 1 plus 2 times negative 6 plus 1 times 4. So that's 4 minus 12 plus 4, right? 4, negative 12, 4, okay. Next color, I guess let's go here. 4 times 0, 2 times 7, 1 times 2. So that's 0 plus 14 plus 2. Last one, let's use gray. We got 4 times negative 1, 2 times 5, 1 times 1. So that's negative 4 plus 10 plus 1. Now let's simplify. 1 minus 4 is negative 3. We already have a negative 2 there. Negative 1 plus negative 1 is negative 2. Negative 6 minus 42 is negative 48, plus 20 is negative 28. Then we got 59 here. We got 41 plus 5 is 46 here. 4 minus 12 is negative 8, plus 4 is negative 4. Here we got 0 plus 14 plus 2 is 16. And then negative 4 plus 10 is 6 plus 1 is 7. That's how you do it. Done. So this one is d cubed. Now, normally I would say, and that's again, d times d times d. So normally I would just be like, hey, let's do d times d first, and then the product of, then that result will do times d again. That's going to take quite a while. But the thing is, in question 45, I did d squared. So you can go back and look and see how I did that. So I'm going to start with d squared times d. So this is d squared, and this is d, right? It matches this. Okay, now let's begin. So we're going to go boom, multiply, multiply, multiply. So we get negative 3 plus 12, right? Negative 2 times negative 6 minus 8. All right, great. Next, we got negative 3 times 0, negative 2 times 7, negative 2 times 2. So that's 0 minus 14 minus 4. Then we do the last column, negative 3 times negative 1, negative 2 times 5, negative 2 times 1. So that is 3 minus 10 minus 2. Next, we go here to the second row. So we got negative 28 times 1, 59 times negative 6, 46 times 4. Big numbers. So that is negative 28. 59 times negative 6, that's negative 354, right? And then 46 times 4, that's 160 plus 24, 184. So big numbers. Next, negative 28 times 0 plus 59 times 7 plus 46 times 2. So the 0 I'm not going to include. 59 times 7, what is that? 350 plus 63. 350 plus 63 is 413, right? 413, and then 2 times 46 is 92. Okay, and then let's go light green. And then we got negative 28 times negative 1, 59 times 5, 46 times 1. So that's positive 28 plus 5 times 59, that's 250 plus 45 is 295, and then plus 46. Okay, now we go to the last row. Let's do this one. So we got negative 4 times 1, 16 times negative 6, 7 times 4. So that's negative 4 minus 96 plus 28. Then we got negative 4 times 0 plus 16 times 7 plus 7 times 2. So that's 0 plus 70 plus 42 is 112. And then 7 times 2 is 14. Okay, last one. Let's do gray. Negative 4 times negative 1 plus 16 times 5 plus 7 times 1. So that's 4 plus 80 plus 7. All right, now as we simplify, negative 3 plus 12 is 9, minus 8 is 1, 0 minus 14 minus 4 is negative 18, 3 minus 10 minus 2, that's negative 9. Then we have this crazy thing, negative 28 minus 354 is negative 382, plus 184, 198. 413 plus 92 is 505. And, oops, 505. 28, okay, let's do it like this. 28 plus 46, 60, 74. So 4 is 299, so 369, right? 369. And then we have negative 4 minus 96, negative 100. So that's negative 72. Then that is 126. And last but not least, 411, 91. That's how you do it. Done. So for this one, based on order of operations, we have to start with b times c. Just making sure that this is doable. It's going to be 3 times 3, and that's correct, right? The columns have to match the rows of the second. That's going to work. And then the resulting will be the number of rows here and the number of columns here, which is going to be 2 times 2 by 2. And then we're going to multiply it by a, which is also 2 by 2. So we're just checking ahead of time, is this going to work? Yes, it's going to be good to go. So now let's start with that b times c. So here we go. First row times first column. We got negative 2 times 0.5, 3 times 1, 4 times negative 0.5. That is, let's see, negative 1 plus 3, and then minus 2, right? Negative half of 4 is negative 2. Next, we got negative 2 times 0.1 plus 3 times 0.2 plus 4 times 0.3. So that is negative 0.2 plus 0.6 plus 1.2. Next, we have negative 1 times 0.5, 1 times 1, negative 5 times negative 0.5, and that is negative 0.5 plus 1 plus 2.5. And then we got negative 1 times 0.1, 1 times 0.2, negative 5 times 0.3. So that's negative 0.1 plus 0.2 minus 1.5. So now as we consolidate everything to get our 2 by 2, we get negative 1 plus 3 is 2 minus 2 is 0. Negative 0.2 plus 0.6 is 0.4 plus 1.2 is 1.6. Here we got negative 0.5 plus 1 is 0.5 plus 2.5 is 3. Last but not least, negative 0.1 plus 0.2 is 0.1 minus 1.5 is negative 1.4. Great. Now we got the final multiplication of a times bc. So let's go. 1 times 0 plus 0 times 3. That's 0 plus 0. Next we have 1 times 1.6 plus 0 times negative 1.4. That's 1.6 plus 0. Then we got 2 times 0 plus 3 times 3, that's 0 plus 9. And last but not least, we got 2 times 1.6 plus 3 times negative 1.4. That is 3.2, what is that, minus 4.2. All right, let's simplify. Our final 2 by 2 is 0. 1.6, 0 plus 9 is 9. 3.2 minus 4.2 is negative 1. That's how you do it. Done. So here we're doing b times a, so let me write that out. So starting off, we got 0.5 times negative 2, 3 times 1, 0 times 0.5. So that is negative 1 plus 3 plus 0, okay? And next, we got 0.5 times 0 plus 3 times 8 plus 0 times 4. That is 0 plus 24 plus 0. And then we have 0.5 times 9 plus 3 times negative 3 plus 0 times 5. So we got 4.5 minus 9 plus 0. Okay, second row. Here we go. Negative 4 times negative 2 plus 1 times 1 plus 6 times 0.5. That is 8 plus 1 plus 3, right? 6 times 0.5 is 3. Okay, next one. Let's go to this color. Negative 4 times 0 plus 1 times 8 plus 6 times 4. So that is 0 plus 8 plus 24. And then we come to the last one. Let's do this one. Negative 4 times 9 plus 1 times negative 3 plus 6 times 5. That is negative 36 minus 3 plus 30. Final row, here we go. We got 8 times negative 2, which is negative 16, plus 7 times 1, which is 7, plus 2 times 0.5, which is 1, okay. Then we got 8 times 0, plus 7 times 8, plus 2 times 4. 8 times 0 is 0, 7 times 8 is 56, and 2 times 4 is 8, all right. And last one, let's go with this color. 8 times 9 plus 7 times negative 3 plus 2 times 5. That is 72 minus 21 plus 10. So we got negative 1 plus 3 is 2. That is 24. This is going to be negative 4.5. Here we got 8, 9, 12, 32, and negative 36, negative 39, plus 30 is negative 9. Last row, negative 16 plus 8 is negative 8. 56 plus 8 is 64. And then 72 minus 21 is 51, plus 10 is 61. Boom, done. For this one, we're doing b times c, so let's write that out. All right, so here we go. We got 0.5 times 1 plus 3 times 0 plus 0 times 1. The only thing that's going to stick is the 0.5. Everything else zeroes out. Moving on. 0.5 times 0 plus 3 times 1 plus 0 times 0. That is just going to be a nice 3. No, don't have to write anything to add up. And then we go here, 0.5 times 1 plus 3 times 0 plus 0 times 1. The only thing that's going to stick is, again, 0.5 times 1. So we got a 0.5 over here. All right, next row. Negative 4 times 1 plus 1 times 0 plus 6 times 1. That's going to be negative 4 plus 0 plus 6, okay? And then we'll go here. We got negative 4 times 0 plus 1 times 1 plus 6 times 0. That is 0 plus 1 plus 0, which is just 1. All right, moving on. We got negative 4 times 1 plus 1 times 0 plus 6 times 1. That is negative 4 plus 0 plus 6. Last row, we got 8 times 1 plus 7 times 0 plus 2 times 1. So that's 8 plus 0 plus 2. Then we have 8 times 0 plus 7 times 1 plus 2 times 0. That's just going to give us a nice 7. And then last but not least, we got 8 times 1 plus 7 times 0 plus 2 times 1. That's 8 plus 0 plus 2. So the simplified matrix is 0.5, 3, 0.5. Negative 4 plus 6 is 2. Then we got 1. Negative 4 plus 6 is 2. Last but not least, 8 plus 2 is 10, 7, and 8 plus 2 is 10. That's how you do it. Done. So for this one, we're going to do b squared, which is just b times b. So let's write that out. All right, so here we go. We got 1 times 1 plus 0 times 0 plus 0 times 0. That's just a 1. Cool. Then we got next color, 1 times 0 plus 0 times 0 plus 0 times 1, which is just 0. Very good. And then let's go to the next one. 1 times 0 plus 0 times 1 plus 0 times 0. Another 0. Interesting. All right, next row. Here we go. We got 0 times 1 plus 0 times 0 plus 1 times 0. Again, all zeros for that product. Then let's go here. We got 0 times 0 plus 0 times 0 plus 1 times 1. That's going to be a nice 1. All right. Next, let's go light green. 0 times 0 plus 0 times 1 plus 1 times 0. Those are all zeros. Okay. Final row. We've got 0 times 1 plus 1 times 0 plus 0 times 0. That's 0. All right. And then let's go here. 0 times 0 plus 1 times 0 plus 0 times 1. That's 0 plus 0 plus 0, which is 0. And last one, let's go gray. 0 times 0 plus 1 times 1 plus 0 times 0. That is 1. This happens to be the identity matrix. Now, since there's nothing really to simplify, we're just going to leave it as is. That's how you do it. Done. So for this one, we're doing b to the fourth, which is b times b times b times b. And I could carry out that repeated multiplication, but it's going to take a lot of time. Instead, what I'm going to say is go back to 55 first, where I found b squared. And then what I'm going to do is I'm going to do b squared times b squared. That's going to give me b to the fourth. So here's b squared and b squared, and then we're going to multiply these, and let's see what we get. So first we have 1 times 1 plus 0 times 0 plus 0 times 0. That's just going to be 1. Next, we have 1 times 0 plus 0 times 1 plus 0 times 0. That's going to be a 0. Next, we go down to 1 times 0 plus 0 times 0 plus 0 times 1. That's a 0. Cool. And then we come to the second row. 0 times 1 plus 1 times 0 plus 0 times 0. That's 0. Next, we have 0 times 0 plus 1 times 1 plus 0 times 0. That's a 1. Next, we have 0 times 0 plus 1 times 0 plus 0 times 1. That's a 0. Okay, final row. Let's go with this color. 0 times 1 plus 0 times 0 plus 1 times 0. That's a 0. And then let's go with maybe brown. We got 0 times 0 plus 0 times 1 plus 1 times 0. Those are all zeros. And last but not least, with gray, we got 0 times 0 plus 0 times 0 plus 1 times 1. That's 0 plus 0 plus 1, which is 1. So b to the fourth is actually the same thing as b squared, which is, again, the identity matrix. So that's how you do it. Done. Using the above questions, find a formula for b to the n. Test the formula for b to the 201 and b to the 202 using a calculator. Okay, so we saw that b squared in 57 and 55, b squared was 1, 1, 1, and all zeros. Same with b to the fourth. So my initial feeling is that, for the ones we tested, when n is even, okay, it's going to be that nice identity matrix, 1, 1, 1, and the rest are zeros, okay? But what about when n is odd? Okay, when n is odd, we're gonna have to see maybe something different. So what we're gonna do for this is instead of multiplying it out, right? And by the way, this is what it is to the first power. So maybe this is what repeats every time it goes to an odd power, but we're gonna test it out in a calculator. So here is that matrix, and I'm gonna say A, this matrix right here, 1, 1, 1, just like how we had it. And I'm gonna raise it to the third power. And look at that, it's the exact same, 1, 0, 0, 0, 0, 1, 1, 0, 1, 0. And let's change it to the fifth power, the seventh power. Look at that, it's always the same, right? Now we go to the eighth power, it comes back to that even thing, 1, 1, 1, just like we predicted. Okay, now it says to verify with 201 and 202, so let's check it out. Let's see 201. Look at that, just like we predicted for the odds, 1, 0, 0, 0, 0, 1, 0, 1, 0. And then for the even, goes back to that identity matrix, 1, 1, 1, and then everything else is zeros. So for odd, like we said, it's basically the original 0, 0, 1, 0, 1, 0. That's what it is for even. That's how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.